Okay, we're kind of looking at sections 1.3 and 1.4 in this video. So they're talking about types of studies: observational versus experimental. Studies. Okay, so now right off the bat, they're talking about observational. Observational is that you more or less just take data as it comes. Take data handed to you. Now, what does that mean? Well, things like surveys, those are observational, because even though you've asked for the data, you are not diving in and messing with the parameters of the study. So things like survey, or just using previously recorded data. So I could do a study on undergraduates and GPAs and so forth. And well, what might I do? Well, I might go into people's transcripts and I want to know about maybe I want to know how do math courses help them out or something like that. Well, if I just go in and ask for the data that was recorded previously, not based on my study, that kind of thing, well, then that's definitely an observational study. But I could even design the study and it would still be observational. I could look at a study about, let's take something like amputees. If I want to study how amputees are getting along, say they were veterans and lost a limb or something like that in service, I might do follow-ups to see how they're doing. Well, that's an observational study. I can design what I want to collect and go collect it and all that, but it's observational. It's not an experiment. An experiment, pretty much you insert yourself. Now, yourself really is in double quotes, into the study. Now, how would you do that? Well, to really do a great randomized sort of study on amputees, what you would do is you would actually get a bunch of people together and with some of them, say, amputate a hand, to see then how they do after that. But you did it. What a horrible idea. That's terrible. I mean, we cannot do those kinds of studies. Now, we have histories of doing those studies. We don't do them anymore. So, for instance, you can look up things like the starvation studies. And we had scientists starving people to see how they would do. What a horrible idea. So there are some studies we just really can't do as experiments. You look at the Tuskegee studies and the terrible things that we did to human beings then. Humans have been very horrible to other humans in many, many ways. And, and you don't want to promote that through a study. And so, there are some studies that we cannot make into experiments, because in experiments we artificially So you insert yourself into the study, and I'm going to say artificially. Okay, you change parameters in a way that affects people, and you know it will affect them, or you are assuming. So studies we can do where we insert ourselves. Music. Does music help a person learn vocabulary words, right? What kind of music and all that? Well, we can set people down. We can play music and not play music, and we can play different kinds of music and so forth. We're inserting ourselves artificially by playing that music into the study, and we can set other parameters. So those are experiments. Observational studies, they tend to have people who are self-sorted, that kind of thing. Like you put something out there and you say, oh, take this survey. Well, if you don't set it up any differently, you're probably going to get a self-selection bias and so forth. Now, as long as you know those things are there, you can work with it, and you can work on ways to try to reduce that bias. But generally speaking, observational studies can't show cause. Okay, and that's an important thing. Many studies are observational, and so even though we might find that association, that relationship, it's not a cause. And then experiments might show cause. In this case, you might use experiments to show cause, but it could be you could set up an experiment and realize that you haven't narrowed down enough of your study to be able to truly say what the cause was. You might narrow it down to, oh, well, the cause was most likely one of these 5 things or one of these 3 things or something. But typically with experiments, we are trying to find a cause in our statistical work and all that. But observations, no. It may point you to something that you say, oh, maybe that's a cause. Well, then you go set up an experiment. And if you can't, because setting up an experiment would be inhumane, then, well, you're just stuck and you can't really find it. Now, I would like to point out, I had already, with data basics, introduced confounding variable. Section 1.3 actually has the confounding variable in bold. And I want to point something out about the text. I'm probably going to make mistakes in this course. I've taught it quite a few times, but I'll probably still make mistakes. But also your authors make mistakes as well. And so on page 14, when they introduce confounding variable, they say they're talking about the sun exposure case or they're looking at skin cancer and so forth, and how much a person is in the sun could be a variable that matters, right? If I'm in the sun a lot, I might be more likely to get skin cancer than if I'm not in the sun that much. And so they mention sun exposure as a confounding variable, but on page 14 they say which is a variable that is correlated, and so at this I'm going to point out that it should be variable that is associated, not correlated, associated with both the explanatory and response variables. Now, in that sense, I also disagree with, they should say it's associated, not say correlated. Now, it could be correlated, but again, that is a technical term. They should be saying associated with. Now, they say with both the explanatory and response variables, and that's also not quite right. And it's associated with at least one of the two, and most likely, if it's truly a confounding variable, it's associated with the response. Now, here's the thing, is if it's associated with the explanatory variable here, and the explanatory variable is associated with the response, then I would agree that the confounding variable is associated with both. But if the explanatory variable turns out to not be associated with the response, well, the confounding variable could be, and therefore it could be associated with the response, but not the explanatory variable here. So that's a bad sentence on their part. This is a great book, but that one sentence on page 14 has a couple problems with it. But it's not way off. Certainly, plenty of good people, including these authors, use correlated when they should use associated. And so at least they're in good company. And then the other is, well, most likely, if we're looking at something as being the explanatory variable, then there's, most likely it is associated with the response, and so you wouldn't have that case. But generally speaking, I want to worry about all the variables that might be associated with the response when I'm trying to design a study. Now, I may decide I can't take care of some of those variables, but I want to think about those variables. I want to think about all those confounding variables. Okay, so again, in these two studies, they're really looking at observational versus experimental. And so you want to pay close attention to that. They mention some other vocabulary and some other sampling strategies, stratified random sampling, cluster sampling, all that. As well as, they mention in the experiments, they mention things like randomization, replication. We want to be able to replicate a study, and maybe replicating groups is a good idea in our study. And now they also, they mention blocking. Now blocking, to me, I really see blocking in a study. Now they mention it in specifically in experiments, but it could be in an observational study. I really see those as going hand in hand. In other words, when you're blocking, so they mention in their definition of blocking, they mention, for instance, if we are looking at the effect of a drug on heart attacks, we might first split patients into low risk and high risk blocks. The risk factor is a confounding variable. Oh, okay, and so then we use blocking for that confounding variable. Okay, so often one way to handle confounding variables is to introduce blocking, or to split people into different groups where we think the confounding variable might matter. And actually, that's exactly what we're going to do in our first project. We are going to use blocking to take care of our confounding variable. And I believe, those are the highlights for that. They mentioned placebo and double-blind studies and blind studies and that sort of thing. But just there's a lot of vocabulary in those two sections, so just make sure you check out all of the different vocabulary as you read it. And then if you have questions on it, sure, ask me questions on the vocabulary. So there you go, and that takes care of those sections.